I welcome you all for this presentation. In this presentation, we are going to discuss about one of the data structures, linear data structures, that is queues. So, introduction to queues. This is the overview of this presentation, that is introduction to the queue data structure, then queue abstract data type operations, then some of the applications of queues. Then I have given one problem to practice, followed by summary of this presentation. So already we know one new data structure in this course, that is the stack data structure. It is first in, last out, or last in, first out. We can call it either way, the stack data structure. The stack data structure is also an abstract data type. Likewise, queue is also an abstract data structure. We all know that what is abstract data structure. That means only the operations and data are known to the user and the implementation details are fully hidden from the user. And some error conditions are also we can have access, but the implementation details are hidden from the user. That is the abstract data type. But in this stack, we are performing both insertion and deletion in only one end called top of the stack. But in this queue, we are doing the operations at both the end. That is the difference, one difference. Both the end in this end, one end is used to insert the data. That operation we are calling it as NQ. In stack, the insertion operation we are calling it as push. Here in queue, the insertion operation we are calling it as NQ. And the other end is to remove the data, that is DQ operation we are performing, or deletion operation we are performing. So by looking into these two pictures, you can easily aware if you are standing in a one-way traffic, our vehicles have to be arranged in a queue. So which vehicle entered first has to go out first. So first in, first out. And which vehicle entered last have to go out last. Then in an airport also, if you are going in for the check-in process, at that time whoever entered first have to go first out. Then whoever entered last have to go out last. So these are some examples. Many more real life examples are available. Day to day we are following many queues. If you want to enter into the bus or train or in banks, hospitals, all those places we are following queues only. The same principle only apply here in order to store the data also. So the definition of queue is that queue is an ordered list in which all insertion take place at one end called rear and all deletions take place at the opposite end called front. So deletion you easily remember, whoever is entering first, they are only standing in the front. So deletion happens at the front end and the insertion happens at the back, that is at the rear end. So all insertions are taken place at the rear end and deletion happens at the front end. And now you please recall, in stack all the operations are performed in the top alone. But here insertions are done at the rear and deletions are happening at the front. So if you are inserting the element A, B, C, D in that order, then A is the first element we have to delete from the queue, and this queue is also called as first in, first out list. Here you can see this example A, B, C, D. First A we are inserting. If you want to perform insertion, what we need to do is we have to increment the rear position, then only we have to insert it. And the front pointer is also pointing to the first element only. Then again we are going to insert B. At that time increment rear. So now rear is pointing to B and we are inserting this B. Now front is in the front position only. Then we are going to insert C. So we are incrementing the rear position to this third one and we are incrementing, we are placing C. Then we are inserting or enqueuing D. So we are incrementing the rear and it is pointing to the fourth position and D is inserted. And in order to perform the deletion, that is deletion is happening at the front. In order to perform deletion, we have to increment the front and remove this element. So here you see the front is pointing to A. So if you are incrementing means it points to the next position wherever B is there. So now front is pointing to B and A is deleted. So this are these two are the basic operations in queue abstract data type. In addition to the NQ and DQ operation, we are having two more operations. One is the three more operations: peek, is full, and is empty. NQ and DQ already we know. NQ is to add an element in the queue. DQ is to remove or delete an element from the queue. Peek is to get the element at the front of the queue without removing it. Which element is placed in the front of the queue? In order to get that, we are having the peek operation. Then is full, it checks if the queue is full, and is empty, checks if the queue is empty. These two we already use it in the stack data structure itself. But here only difference is there with respect to top and the maximum size we have checked. But here we have to check with respect to the rear and front we have to check. That's the only difference. While discussing about the implementation, we will discuss in detail about these all the 5 operations. Next, some of the applications of stack include queue, include waiting lines. Already we have seen. Then access to shared resources. If we want to print 5 or 6 documents, then we are not waiting for the printout, and we are just giving as such one by one. We are just giving it, and we are doing some other job. At that time, how the printer will print the document? Whichever document we have given first for printing, that is only printed first. Likewise, whichever document we have given last, that is getting printed at the last. So this is one of the real-time application we are having in day to day while taking printouts and all. Then in the networking, queues in routers and switches. So the data travel from one node to another or from one router to another. At that time, whichever data comes in or whichever packet comes into the router first, that is forwarded to the next hop. So the queue data structure is followed there also. Then mail queues are also there. That is whichever mail we are sending first, that is delivered first. Likewise, many more applications are there. In addition to this, many applications are there with respect to the operation of the computer. But you all are new to all the concepts, so I am not including all those applications here. So these are some of the general applications, so all of you are aware of that. Next, I have given you one practice problem. So here what you need to do is describe the output of the following series of queue operation. NQ means it is insertion operation. So you have to draw a queue. Here you have to insert in the front. Now insertion happens at the rear. Rear wise only we are inserting. Now here we are having rear as well as front. Then again I am performing NQ operation. What I have to do is already we have to increment the rear position. So incrementing the rear position becomes this one. So I am inserting 3. Front is in the front of the queue. Then I am going to DQ it. So what I need to do, I have to increment the front position. So now front becomes here and I am removing this one. Then I am performing NQ operation. So I have to increment the rear position. So now 3 is in the front. Then I am incrementing the rear position. So 2 I am inserting. Likewise, you have to follow all the operation and you have to check whether here the maximum size of the queue is not given. If the maximum size of the queue is given, at that time you see the underflow as well as overflow condition also. So up to this I have shown. So remaining part you try to work out. So in this presentation we discuss about introduction to the queue data structure. Then we discuss about the queue ADT operations like NQ, DQ, then peek, is full and is empty. Then we have seen some applications of queues. Then I have given you some series of calculations for insertion and deletion in the queue. Thank you.